Alright, I realized after I started the 5.2 recording that it was going to be a lot longer than I expected. So this will be your last recording. Make sure you still have your 5.2 notes or your guided notes because the 5.3 will continue on there. And we'll start with the tree diagram part. Okay, so at the bottom of your notes on one of the pages, the first little thing should be a tree diagram. So this is where we'll start and then we'll finish. Okay, so a tree diagram, it helps you see and count the total number of outcomes in an event. Okay, so basically for the tree diagram, what you're doing is you're listing the entire possibilities. So they're going to be pretty big. So if you go down to this example here, you flip a fair coin 4 times. You want to list all of the possible outcomes. So when you list all possible outcomes, that's also just called the sample space. So we have 4 flips. So I'm at the top, I'm just going to write first, and then second, third, fourth. Okay, so on the first flip, we have 2 options. We can either get a head or we can get a tail. Okay, now is where they kind of get a little bit confusing. So since we have 2 options when we flip a coin, after every single possibility, we're going to have 2 more options. So here at heads, for my second flip, I'm going to have a head or a tail again. Okay, same thing for tails. I have 2 options after I get a tail. I can either get a head or a tail on my second flip. Okay, now we're on to the third flip. So I'm just going to look at the very first head up here. Since we have 2 options, we're going to have 2 options again, a head or a tail. Go down to this tail here. We have 2 options, head or tail. Okay. For this head, we have a head or a tail again, and then head or tail. I'll go through how to read the tree diagram in 1 second when we finish filling it out. So for the fourth flip, all of these possibilities right here, they have 2 options again. So we have head, tail for each one. Okay, so when we read this diagram here, we're always going to start with our first flip. So let's say I'm just going to list a possibility. So on the first flip, let's say I get a head. So flip 1, I got a head, so I'm going to go here. So then I can either get a head on my second flip or a tail on my second flip. So let's just say I got another head on my second flip. So first flip was a head, second flip was a head. So from the second flip that was a head, I can get a head or a tail again on my third flip. So this time let's say I go down to a tail. So from this tail here, I can get a head or a tail again. So let's just say head. So there are multiple options. So if I had a first flip of a head, again, I have 2 options for my second flip. So I could say I got a head for my second one. On my third one, I have 2 options. So I could have flipped a head again. Fourth flip, I have 2 options. So I could have got all heads for all of them. Okay, so there are multiple possibilities. I'm just going to list one. Okay, so here on our fourth flip, if we count all of these right here, it means that we have 16 total possibilities for our fourth flip. Okay, so since 16 is the biggest sample space, that's going to be our denominator for our probability. So we want the probability of each outcome. So we have the probability of an outcome. So we said 16 was the total. And when it says of each outcome, we're only looking at one outcome. So what I want is just one outcome. So my probability of each one would be 1 out of 16. Okay, there are no tree diagrams on your test because they are kind of weird to read and to fill out, but you will have some for your homework. And so when you're filling it out, just make sure you look at whatever it's asking. So here we flipped a coin, so we know we always have 2 outcomes. Next thing we're going to go over is the fundamental counting principle. Okay, so fundamental counting principle says if there are n outcomes, n is just any number, for one event, and m outcomes for another, then there are n times m total outcomes. Okay, remember n and m, those are just any numbers. Okay, so for example, you can get 10 different toppings on a pizza. You have 3 choices of crust, and you can choose between 2 sauces. How many different one-topping pizza combinations exist? Okay, so this uses fundamental counting principle because we just have a different quantity for each outcome. So we have 10, 3, and 2. And we want to know the total outcomes, or the total combinations. So we're just going to multiply them together. So we have 10 times 3 times 2. So we would have 60 outcomes, or 60 combinations. So anytime it just tells you the number of outcomes and you want the total, just multiply them both together, or them all together. All right, last thing we're covering. Okay, so first we're going to go over permutations and combinations. So for a permutation, we need to have that order matters. Okay, so when I say order matters, we're thinking of like the number of ways to arrange in distinct objects in order r at a time. So n and r are just numbers again. Okay, so when we think of order matters or think of arranging them, remember, think of distinct positions. This will help you determine if it's permutations or combinations. So if they have specific positions or a specific order they go in, then it's a permutation. Okay, and the way we write this is a small n, capital P, and a small r. So NPR. This stands for permutation. Okay, the n, when we go to probability, think of n as the total. So like if we were rolling a die, we have 6 total outcomes. So for a die, the n would be 6. If we were dealing with a deck of cards, there's 52 cards, so n would be 52. So n is just your total. And r is kind of like what you want or what you're looking for. Okay, so combinations. order does not matter. So number of combinations of n objects are at a time. So n and r mean the same thing. N is the total again, r is just what you want or what you're looking for. So since it's a combination, we have a small n, capital C, small r. So that's just the notation for it. Okay, so on the calculator, there are 4 steps. The first step, we're just going to enter whatever n is into the calculator. So if n is 5, I'm just going to put in 5. Okay, and then the second step, I'm going to go to math, over to probability, and then I'm going to select option 2 or 3. Okay, it depends if I'm doing permutation or combination. And then I'm going to hit enter. Step 3, I'm going to enter whatever number r is, and then the final step I'm going to hit enter on the calculator and it'll tell me the answer. So you will not hit this final enter button until you have all 3 of them in a row on your calculator. Okay, so first thing, we're just going to look at a couple examples and see if they would be a permutation or a combination. So how many different groups of 3 people can serve on a committee if 12 people from the board are chosen? So remember permutation, we said that it was order matters and there's distinct positions. Combination order does not matter. So here we have different group of 3 people can serve on a committee if 12 people are chosen. There are not distinct positions in the committee, so this one would be a combination. Okay, if it was talking about president, vice president, secretary, those are distinct positions, so that would be a permutation. But here it just wants to know how many different ways or how many different groups. Okay, how many different awards for first, second, and third place could occur if 20 people entered the contest? So again, remember permutation, distinct positions, combinations, doesn't matter. So here they tell us there's first, second, and third place. So those are distinct positions. So this one will be a permutation. All right, couple examples and then we're finished. Okay, so suppose you draw 5 cards from a deck of 52. We want to know the probability of each of the following. So the first one, we want the probability of 5 hearts. Okay, remember probability is what you want over the total. Okay, so first we need to figure out if this is a combination or a permutation. Okay, I know there's other ways to do it, but we're going to use it or do it with those 2. Okay, it does not matter what order we draw those 5 hearts in, so we know we're going to have a combination for each one. So I'm just going to go ahead and write my C's. Okay, so if I ignore my denominator, the numerator, remember in probability, is what you want. Okay, so I want 5 hearts. So I'm dealing with hearts. So remember the notation for combination is NCR. So we know N was the total. So if I'm dealing with hearts, there are 13 hearts total. And the R was what I wanted or what I was looking for. So I want 5 hearts. So my R is going to be 5. Okay, now let's look at the denominator. So with probability, the denominator is the total. Okay, so I'm dealing with a deck of cards. So I have 52 cards total. So my N, or my total, will be 52. and then R is what you're looking for. So I'm looking for 5 hearts, so I'm going to have 5 here. Okay, the hint or trick when doing these, this number here and this number here, they should be the same, or they should add up to the same number. So 5 and 5. Okay, so now when we calculate it on our calculator, let's calculate the numerator first. So remember, I'm going to plug in n first. So my n is 13. So I have 13. Do not hit enter or anything like that yet. I'm going to go to math, scroll over to probability. So you got to go 4 to the right, or 3 over. And then we're going to select option 2 or 3. So if you look, option 2 is a permutation, option 3 is a combination. So since I have a key or a C, I'm going to select option 3. So now I should have 13 NCR, and then my cursor should be blinking. So after that, I'm going to plug in whatever my R is. So my R is 5. So this should all be in the same row, and now hit enter. So we should get 1,287. Okay, now I need to do the same thing for the denominator. So I have 52 for my n. Now I need a C, so I'm going to go to math, over to probability, select option 3, and then my R is 5. So we should have 2598960. Okay, and you can go ahead and reduce that or write it as a decimal, that's fine, or you can just leave it that way. Okay. If I write it as a decimal, I'm going to get 0.000495. Okay, we're going to do another one. Okay, so second one, I want the probability of 3 kings and 2 aces. So the probability of 3 kings and 2 aces. Okay, so I know, again, it doesn't matter what order I draw them in. So I'm going to have I'm going to use combinations. So I'm going to have one combination in my denominator for the total, and then I'm going to have one combination for my kings times one combination for my aces. Okay, so let's look at the kings first. So here, my first C, I'm dealing with the 3 kings. So remember the n goes on the left, and that's my total. So I'm looking for kings. There are 4 kings in a deck. Okay, and then R is how many I want. So I want 3 of them. So 4, and then C, 3. The next one, I'm looking for 2 aces. So I want aces, so aces are my total. So there are 4 aces in a deck. But I only want 2 of them, so my R is going to be 2. So for this C down here, this is my total. So we're dealing with a deck of cards again. So the total is 52. Okay, so here I have 3 and 2. So remember, these numbers added together should be the same as this number. So since there was nothing to add this to, they should just match up. But these, since they're both in the numerator, we need to add them. So 3 plus 2, so I'm looking for 5 cards total. Okay, we'll go ahead and do this one in the calculator, and then we'll stop using the calculator. So let's just calculate each one separately. So we have 4C3, so I'm going to enter 4. I'm going to go to math, over to probability. I'm looking for C, so I'm going to select 3, which is C. Now I have to enter a 3, hit enter. So that equals 4. Okay, the second one, I need 4C2. So I have 4, math, probability. I'm looking for the C, so I'm going to select option 3 again, and then 2. So that's 6, so we have 4 times 6. Okay, we can go ahead and calculate 52C5 again, or it's going to be the exact same as this one here. 52C5 was 2,598,960. So 4 times 6, 24 over your denominator. Okay, last one of these. We have probability of 4 aces and 1 7. Okay, so I'm going to set up my fraction. I'm looking for two things. So we're using combinations still since order doesn't matter. So I have 2 c's in the numerator. And then my total, I just have 1 c. So if I start with my 4 aces, so remember on the left is the total. There are 4 aces in a deck. So I'm going to put a 4 there. I want 4 of them. So we have 4c4. For this one, I want 1 7. So again, there are 4 7s in a deck, and I only want 1. And then down here for my total, we have 52 cards total, 4 and 1. So I want 5 of those cards. So 52c5. Okay, and then final step, just plug all these into your calculator and it'll give you your fraction. All right, last example. Okay, so a jar has 22 nickels, 13 quarters, and 18 dimes. Okay, 6 coins are drawn randomly. What is the probability of getting 2 nickels, 2 quarters, and 2 dimes? So first thing I'm going to do, I'm just going to look at the total number of coins in the jar. So we have 22 nickels, 13 quarters, and 18 dimes. So that means I have 59 coins total. So I want the probability of getting 2 nickels and 2 quarters and 2 dimes. Okay, so we need to figure out if we're using combination or permutation. So again, it does not tell you that you have to draw them in a certain order. So we're going to use combinations again because order doesn't matter. So I'm going to have a fraction. For my numerator, I'm looking for nickels, quarters, and dimes, so 3 different things. So I'm going to have 3 c's. And then my denominator, I have 1 c for my total. So let's start with the nickels. So I want 2 nickels. If we come back up here, there are 22 nickels total. So my total should be 22. And I only want 2 of them. So 22c2. My quarters, if I come up here, there are 13 quarters total. And again, I only want 2 of them. So 13c2. And then the last one, I want 2 dimes. Up here, there's 18 dimes total. And we only want 2. Okay, and then for this total down here, there are 59 coins total. And I am trying to get 6 coins. And we have 2, 4, 6, and then 6. So your numbers should match. Okay, so again, remember to start with your totals. See if you're using permutations or combinations. However many different things you want, you need that many different c's in your numerator or p's. And then in the denominator, you're only going to have 1 c or p. And remember, this is the total for the whole problem. Okay, that was the last example. So here's your assignment. Remember, if you have any questions, please email me. Okay, on Monday, you can go ahead and you'll do a review like normal. On Tuesday will be your test, and I will grade those tests. Okay, so any questions, if you have trouble with something, make sure you email me.